Okay, this is my layout for doing a breadth-first traversal using a queue. Now this layout and method works for a tree and for graphs. So I feel that with one method for two problems, that's the advantage. We only have to remember one thing. Okay, so in my method, you always lay out your table like this. Okay, so I'll take you through the items. Okay, that make up the table. Okay, so breadth first traversal uses a queue. So here's our queue, and we label the front and back, so there's no confusion. Also, we're telling the examiners clearly which sides are front and back. Okay, and then this is the current node we'll be working on, and this is the visited node list, and this will give us our final list of nodes in the breadth first traversal order. Okay, the next two steps are just to help us remember the process. Okay, so NQ each child or neighbour. Okay, child refers to if it's a tree, and neighbour refers to if it's a graph. That is not in the visited list, i.e. this, or in the queue, okay? And when we do the algorithm, that step will be clear. It's quite straightforward. Okay, the next step is set the current node equal to the DQ of the queue. Okay, so I'll just leave this table up so you can see how to lay it out for the very start. Okay. Okay. Now we're going to do the traversal. That's the easiest way to see how it works. Okay, we're starting at the start node, which is A. So we put that A into the current node. We simply copy it then into the visited node list. Then we do this step, NQ each child or neighbour that is not in the visited list or queue. So the children of A are B, C and D. So we need to put them in the queue because they don't appear in our visited list or in the queue. So we'll put them in. So B, C and D. Okay, so now we've done that step, we just put a tick. And now we need to do the next one. Set the current node equal to the DQ of the queue. So we'll DQ the queue, just put one line through it so the examiner can see what you've done and put that into the current node. So we've done that step. Okay, we just copy into the visited node list, and then we need to NQ the children of B, or the neighbours of B. So if I rub that down, so at B, and the neighbours of B that are not in our list that are not in the visited list and in the queue is just E. So we put E on the queue. Okay, so we've done that step, and now we take the current node and we set it to be the value of DQ in the queue. So that C comes off the queue, and we set it to the current node. We've done that step. We copy that down into the visited node list, and then we NQ each child of C, and D, that is in the queue, so we won't add that on to the, we won't NQ that, and then that's all. So we've done that step, and now we need to take the current node off the queue. So we'll do that. We'll take off the D and we'll put that in the current node. We've done that step. Copy the D down, and then we need to do the NQ again for the children of F, or the or the neighbours of F that are not in our visited node list or our queue, and that is just F. So we put F on here in our queue, and we've done that step, and the current node is going to be set to the DQ of the queue, so let me get the E there, and we've done that step. We copy the E into our visited node list, and we're looking at E, and the only node is G that is not in our visited node list or queue, so that's G, so we put that in our queue. So we've done that step, and then we DQ the queue. So we take the F off there and we put it on the current node list, and then we copy it into our visited node list, and we are looking at F, and there are no neighbours to add onto our queue, so we've done that step, making the current node equal to the DQ of the queue, so that G comes off the queue, and we put that onto the current node. We've done that step. We just copy that into the visited node list, and now we look at G, and it has no other neighbours that are not in the visited node list or on the queue. So we've done that step, and we set the current node to be the value of the DQ, but we don't have anything on the queue, so we've done that step, and that is the end of the algorithm. So now we have the breadth-first traversal order of this graph. So it's A, B, C. So as we expect, this is what breadth-first traversal gives us. It's the level by level, starting from the top. So we have that as our A, and then we have B, C, D, and then we have E and F, and then finally G. So that's the end of the process.